All right, so let's look at manipulating series. So this is when you take a series that is either given to you or a series that you have memorized, and you need to alter that series to create a new series. Three series that are worth memorizing are sine x, cosine x, and e to the x. E to the x is definitely the easiest one. It does not alternate. It's just x to the n over n factorial. You don't skip any powers or anything like that. But sine x and cosine x, you'll notice they do alternate, and you are skipping factorials as you work your way through. The easiest way, I think, to keep these straight, well, there's two ways, and they're both relatively easy. You should know that sine x has origin symmetry, which means it is an odd function, and you notice it has all odd exponents. Cosine x is an even function, has y-axis symmetry. You'll notice that it has all even exponents. The second way you can keep these straight is when you are at the center of a series, and these are all centered at 0, the Taylor polynomial gives you exact values for your function and its derivatives. So you should know that at the center of this series, sine of 0 will be 0, and the cosine, undo that, the cosine of 0 is 1. And so if you can remember the two formulas, but you forget which one goes with sine and cosine, just think, what if you replaced all of the x's with a 0? This one would return a 0, and this one would return a 1, which means that the top one must go with sine x, this middle one must go with cosine x. So there are a couple of ways you can keep those straight if you have a hard time keeping your sine x and cosine x Taylor polynomials straight. So let's look at a couple examples where we will manipulate those known series. So starting with this one, you want the first 4 terms, and I probably should have put the phrase non-zero in here, because every now and then manipulating a series in a certain way will knock out one of the terms, and they typically on the AP exam will ask you for the first so many non-zero terms, and in this case we want the series for x times sine x. So we're going to have to think about our memorized series for sine x, and what would I do to that to create x times sine x? And this is going to be pretty straightforward. We have sine x. If I want x sine x, I will simply multiply the sine x by an x. However, if I multiply sine by an x, I have to multiply everything in this equation by an x. So I could multiply this general formula by x. I also need to multiply this by x. Now, this problem does not ask for a general equation. So really, I can ignore this middle piece right here. And my series for x times sine x, I'll just distribute this x. X times x is x squared. X times x cubed, x to the 4th, x to the 6th over 5 factorial, and x to the 8th over 7 factorial. And you are done. It asks for the first 4 terms. Do not write plus dot, 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 because that suggests that there is more to it. And there isn't, because the question asks for only 4 terms. So I will not write the dot, 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 which makes me realize I made a mistake, because this series, because I terminated it, I did not go on forever. It is no longer equal to x sine x. It is now an approximation for x sine x. Little technicality there. Okay, so here's a similar one, right? The first 4, again, I should have added the phrase non-zero here. First 4 non-zero terms and the general term. So here we need the general term also for the series of f of x equals e to the negative x squared. And so we're going to have to think about my memorized series for e to the x. And so e to the x is equal to that series. And I'll throw the general term over here, x to the n over n factorial plus dot, dot, dot. And I want a series for f of x. Well, what I need to do now is think, what did I do to e to the x to turn it into e to the negative x squared? And I did that by replacing the x. I took this x out completely, and I put a negative x squared in its place. A way you could write that with good math language is we could define e to the x to be another function. Since f is taken, I could call e to the x g of x, and then I could say the e to the negative x squared, it's really the same as my g function, only I replaced the x with a negative x squared. So I'm going to go through this formula right here, and I'm going to take all the x's out and replace them with a negative x squared. So that would be 1 plus a negative x squared plus negative x squared squared over 2 factorial plus negative x squared cubed over 3 factorial plus dot 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 plus negative x squared to the n over n factorial. And I did have to do that last part because it did ask for the general term. And so I needed to do the general term with n's in it as well. You could stop here for this. That does answer the question. However, if this were a free response question, which is what you will see on the AP exam, you typically use these answers and later on in the question. So it helps you, it becomes advantageous to clean this up a little bit. So this one will end up alternating. A negative squared will become positive. X squared squared is x to the 4th. And usually after the first 2, maybe 3 terms, you'll start to see the pattern. X to the 6 over 3 factorial plus dot dot dot. And then the general term, I'm going to separate that out. Negative 1 to the n, x to the 2n over n factorial. And there's my general term, and there's my answer. So the very last one I wanted to look at is going in the opposite direction. So the first 2, I gave you the equation and we created the series. Here we are going to unpack the series and find the equation associated with that series. So I'm thinking about my series, sine x, cosine x, and e to the x, and I want to know which of those 3 I am manipulating. And to determine that, you look in the denominator at the factorials, because prior to simplifying these, no manipulation will change those factorials. Manipulations can change, and they will change the exponents, the coefficients of the x's. They can change a series from alternating to not alternating, or vice versa. And so we want to focus on these factorials in the denominator. And if we go back and look at the 3 series, sine, cosine, and e to the x, cosine is the one that has 2, 4, and 6 factorials. E and sine do not. So we're going to figure out what in the world they did to the cosine series to turn it into this. And the only change I see is in the numerators up here. So I'm going to get rid of that. I noticed that my 1 didn't change. And so since 1 didn't change, that tells me that I didn't multiply an x squared through. Because if I multiplied an x squared through, that would have changed the 1, and I didn't do that. So what we must have done on this one is replaced the x with something. And so I am plugging something into the x, and whatever I plugged in, it gave me these numerators. So let's look at 4x to the 4th. That 4x to the 4th would have been the result of squaring something. This 16x to the 8th is over 4 factorial. That comes from raising something to the 4th power. And it's not too terribly difficult to figure this out. 2 squared would give me a 4, and x squared squared would give me x to the 4th. Let's verify that. Down here, 2 to the 4th is 16. X squared to the 4th is x to the 8th. And so that checks out. And so this series would have to be the series for cosine, not of cosine x, but cosine of 2 to the x squared. And always pay attention when you're unpacking the series. It's easy to overlook the alternating part. Nothing happened to change the alternating. It's positive, negative, as was the original cosine. So we don't have to worry about attacking that. If it does change from alternating to non-alternating or vice versa, usually that just means there is a negative squeezed in here somewhere when you plug it into the function. So there is manipulating power series. Hopefully that made some sense. If you have questions, let me know.